Morning, everybody. Welcome back to our webinar series. It's great to have you again. Today's session is part 2 of our scripting webinar. If you've missed part 1, don't worry. If you registered for part 1, the link for playing back the webinar will be in your inbox. If you don't have a link, please comment directly or just pop a question in Q&A and I'll email you the link. Just like last week, today's session will be followed by a live Q&A. Feel free to submit your questions throughout the session and we'll answer those questions during Q&A. If there's any that we don't respond to, we'll contact you directly with the answer. Thanks again for being here. Jennifer, over to you to introduce today's session.
Hello everyone, thank you for following us already for the first session and welcome into the second part of this webinar. If, as Joel said, if you were not able to watch it, hopefully you've had time to watch the recording of the first part. Otherwise, I'm sure you will still be able to follow today's session as we're really doing this for beginners and doing it step by step. If you've got any question, obviously put them in the chat and we can answer those at the end. So we are going to continue exactly where we left the script in the first session. So we've seen how to start a script using a text editor and finding functions in the 3DR help, which is how to get started really. So what we've learned, especially in the first session, was to get an object that's already selected by the user, check this selection and use it to run a function on it. So what the first script did was getting a point cloud that was previously selected by the user, then run the script and run the indoor construction classification model on that point cloud, and display the point cloud with that classification inside the scene. And that's where we stopped last time. The next step now will be to extract only one particular class out of the point cloud, and in this particular case we'll just do the pipes, and see how to manage that. So let's get into it. So let's do the next part of our script. We have classified the main point cloud. Now we would like to explode it into different clouds according to the classification. And that's the step we're in right now. So we need to find out what's the function that can do that. Let's go back to the help file. And it's going to be within the S cloud because we're doing that on a cloud. And if you know a little bit the vocabulary from 3DR, explode is most probably what it's going to be. And here we are, explode by class, explode color. It's explode by class that we're after. So I click on one. And we see the description here of the function. Very easy, there's nothing to put as an input. We'll just run it on the cloud to explode, and then we'll have the return values just as always. So we'll need to use explode by class. So as always, I will have my return value. So result of the explode by class will be, which one is the cloud to work on? Is this one, my classified cloud? So I'll do that. Classified cloud dot explode by class. Here we go. So I'll just copy that as my comment. And now we have to check the return just as always. So what we see is that we have an error code and then a table that includes the clouds, so the various clouds exploded, and then a table that will show us the corresponding class. So this is where it's the sort of thing that can be a little bit tricky in scripting, manipulating arrays and so on, and tables of elements, but we'll see that shortly. So what we need to um, do first is check that this exploit by class has actually worked, and then we'll get into using the result of it. So the first thing to do, instead of checking every error message, I will check if the number is just different to 0, it means there's been an error. If it's equal to 0, then we can go further. So what we'll do is that I can easily just copy this line here, and you just have to be careful to check the right result. So result from exploit by class, if it's error code, it's different from 0, then throw an error and we can say explode by class failed, and that will throw an error that will stop the script. Now to check the result, what we can do is make sure that the resulting table of clouds actually contains clouds before we start working on those clouds. So what I'm going to do is I can say if, just like before, I can use this. I might copy all that. If the cloud table included in this result is equal to 0, it means no cloud exploded. So we're going to stop the script as well. That's it. I'll save that. Now, we won't see anything if we just test it like that compared to what we had just here. So what we need to do is actually add those clouds into the document to be able to see what has been done. So we will switch and do that at the same time as we find out which cloud corresponds to the pipe class. So here what we need to do is, because we have a table of clouds as a result, what we need to do is go through that table and check every single cloud to check whether that cloud is the one corresponding to the pipes or not. If it's not, then I could just ignore it, or I could create it and hide it, whatever is the best for my script. And if it is, then I can add it into the document and potentially give it a name, etc. So how do we go through all the elements of a table? A very easy way is to have a loop, and one way of writing a loop is to use for. So for certain conditions, we'll be doing certain actions. So you open the loop like this, and then whatever actions have to happen, as long as those conditions are respected, it will be written within these brackets. So usually the way we go through a table is that you declare a variable that will be the index of the element to look at. So let's say we start with the element number 0. All the tables start with index 0. So my index cloud will be, the starting point will be 0. The condition of it will be that this index needs to be smaller than the number of cloud in the table, because if we get over that number, then obviously there won't be any clouds there, because that's the end of the table. And then what you write is eCloud plus plus means that as soon as we're at the end of the loop, if we go back into it, we increment iCloud plus 1 and run the same loop with the next index. So this here means that we'll run whatever action is here with every single item that's within that table. So we start with the 0, and if the table contains 3 elements, for example, it will be 0, then incremented to 1, then incremented to 2, and because this contains 3 elements, as soon as iCloud reaches 3, it will not be compliant to this condition anymore, which means we will be thrown out of the loop. One thing to make this a little bit more readable is that I could say here number of clouds, for example, and instead of writing that, I could say the number of clouds is the length of that table, and then just use this here, which makes it a little bit more readable. And what I can do is even declare this higher up right here and say if the number of clouds is equal to 0, then no cloud has been exploded. So you can get that variable as soon as you need it, and then you just call it each time you might need it again. Makes the script a bit more readable to put under a variable something that you a value that you need more than once throughout the script. So we know already how to get a cloud, and very often I would say just like that, the cloud I'm working on is inside that table, and to get the right index, now instead of writing a number in there, I write iCloud, which will give the index that we're after. Now we also need to get, and this is what this tells us, we also need to get the corresponding class. So the idea is that if we get the class from the same index, so it was class table, this variable will tell us what is the class from that cloud. Now it's not that easy because this is not a table of strings. So it means this doesn't include texts that tells us, okay, this is the floor, this is walls, these are pipes. It's giving us a number. And this is where you have to navigate a little bit the 3DR help to find out what we're after. So if we have a number for a class, how do we get its name? Because I don't know what is the number of the class I'm after. And if we stay inside the cloud, you'll see that when you're after an information, very often it starts with get. And you see right there, we've got get class name. So that's most probably what we're after. Get the class name for a given class ID. And you see that this function gets a number as an input and will output, we'll see it here, the name, which is the string, those are the name of the class. So this is what we need to be using. So let's write that in here. The result of the function will be res class name eCloud scloud dot get class name, the class class. So the class is the number returned by um, the explode byte class that we had earlier, right? Here I can say get the class name for a given class index. Now, if I want to check that this isn't it returning me a text, a string, what I'm after, there's one thing that could be useful when you're testing the script while you're writing it, and it's function that's very simple. It's called print. That allows you to print any information within the little dialog box of the scripting on the right side, and it can show what has been just extracted. So what we'll print, and I'll show you how that works, is that I can print just a single message, so class name, like this, but I wanted to show me the variable that's the resulting class name. So what I'll do is I'll do res class name dot name, and I'll say print the current class name. So that's the result of the function, and as you see here, the dot name is what we're after. So in this case, I'm not checking the error code, but we should potentially do it as well. Here we go. So let's test that. If I save that, going to 3DR, Control Z, select my cloud, and launch the script. Here we go. So in the view, we still have the same result as before because we haven't added any action per se. But here now you can see that the way we were retrieving the class name seems to be correct because we have each time class name with every single class that is included in this classification. So this seems to be correct. Remember this little trick, this print function here, very useful when you're while you're writing the script. You probably don't want this to happen once the script is finished. So a little tip I have as well is that for these things to happen only while you're writing the script, I usually create at the top of the script a variable that I'll call debug, and I have it set to true while I'm writing it. And then whenever I'm creating things that are really only useful while I'm writing the script, I'd say if debug, then do that. Which means that once I'm finished with my script, I can simply turn that to false, and this line will not happen because debug will be false. So this is not a true statement anymore, and this will not happen. So very easy like that to not have code that you might write in there just while you're writing the script and then deleting it to clean up your script at the end, because deleting lines always creates a risk of creating issues, and then there's part of your scripts that might not work anymore because actually you deleted a bit too much, or you created another variable in there that you're actually using later, etc. By having this little variable debug there, you make it much clearer. And one more thing we could do is, for example, just up here, we were adding the full classified cloud inside the view, what we see right here. we don't really need to do that because this in this script what we want is only adding the pipes at the very end. So I could actually put these two lines within the debug as well. So I could do that and then this and that. And that way, adding the cloud and setting its representation is only done if I am actually debugging this script. Let's save. Now, what we need to do is this string here, sorry, class name dot name, we have to now compare it to to what we actually are after. So what is the class name we're after? It's pipe. You can see it here. It's what's called just pipe. So we can easily here just say if rest class name dot name equals pipe, then keep going. Or we can do exactly the same as what we've done for this one, the model name. We could say a variable here. We can say class name. I'll say to keep. Maybe just class to keep. And here I can say pipe. The name of the class to keep. And that way, if you're running this script again, it will be very easy to simply replace this by HVAC, for example. If you need another element or in running that on another data set, for example. So much easier to adapt those parameters if they're straight at the start of the script than if they are somewhere inside your lines in here, because you would most often forget to change it in multiple places. So put it at the top, always the easiest. Now, what we need to do is compare the name here to the class to keep. So what I might do is that I might create just another variable here to make it cleaner. I'd say current class name equals, and we'll say equals that. And that way I don't have to call the dot name each time. I'll put a little space here as well. So now the best thing to do usually when you're comparing a value and then having action is that basically if the class name is the same, then we'll do some actions, but it's actually easier to write it the other way around. If the name is not the same, then what we'll do is that we'll simply move to the next iteration. And so the way we write that is like this. If current class name is different from, what did I call it? Class to keep. Then you just write continue. I'll just move that over. This means if the current class name is not the one we're after, then continue. Continue means we don't go to the lines that are after, we go straight into here and increment the iCloud to the next number. So basically nothing happens if the name is not the one we're after. Otherwise, which will be the next thing, what we can do is that we can then add the cloud into the document. So the cloud point add to doc, and the cloud to the document. And if you've looked here, what you can see is that by default, a cloud just has a name called cloud. and then a number. So if I was playing this script over and over, you'd have cloud 2, cloud 3, cloud 4, etc. That's just an automatic naming. So it's absolutely possible to give a name to an element when you're adding it into the document. And that's an easy function, is this one, set name. So when you want to get an information from an object, it's get, and when you want to modify an information, it's set. So that's how you find those pretty easily. Set a new name for the cloud. So what are we going to call it? We probably want to call it, we can still call it cloud because it's still a point cloud. So I might do it like that. And then we can use exactly the same as what we've done here. We'll say plus, and we want to give it the current class name that we've got. Here we go. Let's see how that works. I'll save that. Now, go back, select the cloud, start the script. Here we go. So we're still having all of these being printed. So there's pipe and all the next ones. And here what we can see is that we've got the classified full point cloud that we kind of need to hide now. And here is our point cloud that includes just the pipes. So just to make it a bit better, we might hide that cloud so that as soon as the script is done, we actually see the result straight away. So we'll do pretty much the same as what we've done earlier. Set visibility false. And what we can do is that it's the classified one. So we just have to be a bit careful because we only have added the classified cloud in debug mode. So I'll add this condition before as well, like this. And now the second thing that we could improve a little bit is that here you can see that even though we found the pipe, it's still going through the end of the table here. So what if pipe was number 2 and there were 100, 200 classes? Who knows? Well, it wouldn't be very efficient. So what we need to do is write something here that would make sure that if we found the right class, then we actually just go straight to the end and we don't run through the rest. A very easy thing to do is say that our index iCloud is actually equal to number of clouds. And that way, jump out of the loop, because this condition here, this condition will not be valid anymore, which means we'll jump out of this loop here. So what we can do is, for example, this pipe here, it's just in the smooth representation by default. This is the default representation for a cloud. So we could potentially just change that as well if we wanted to have it either in maybe just in RGB, so we see the color of the each pipe, and then we can model it accordingly. So maybe let's just do that. So how do we change the representation? We did that earlier right here, so we'll just copy that and do that here as well. So it's the cloud that we're modifying, and we're not going to choose the classification. What we'll choose is, we'll have a look quickly in here. go back to that function. We might use the colored one, cloud colored. So I'll just copy that. Display in RGB. So you can only do that if it does have RGB values though. But in theory, you know what type of data you're working on. I think that's it. The one thing I can add to make it a little bit even nicer, you've seen this here, print. We can print information. So you see that the progress bar when we run the classification takes a little bit of time. So you're kind of always hesitating. Has it started? Has it not? So what we can do is that in front of each, before each step, you could print an information. And for example, here, before the classify, I could say print, and I could have a little message saying classification started, like that, for example. Print a message to the user. And then I could print the same thing once it's been finished. So I can say here, classification done. And we could then say explode by class started. And then we can do that just after, export by class, done. Again, this could be simply in debug mode as well, or in the script itself. You can put whatever message is relevant in there. Here we go, just added a couple of messages in there. We will save that and run it one more time. So I'll go back. And select my cloud, run the script. Classification started. Here we go, and we've got our pipes like this in RGB ready to be worked on. And we can see here it stopped at pipe, so that's what we wanted. And we got a bit of information throughout explode by class done, etc. And at the end, you always see how long the script lasted as well, which is a good information. If ever it's a longer script and you don't stay in front of the computer. And here we've got our cloud pipe. So now I'll just go back one more time because the last check is to run it without the debug mode. So what I can do is actually don't run it as an external file, but just come in here and I can actually change a value right now in this view. So if here I say false instead of true, I select my cloud and I run it again. I won't have the extra cloud created in here and all the extra information that was useful only for the debug. Here we go. So we only have the messages and none of the debug info. And now you understand that what we can do here, just modifying that, I could write another class right here and just show my cloud again, change the class name, select it, and run it with that other class name without changing the script itself, but just adapting. So this is why it's quite useful to have those variables at the very start. Here we go. I hope you enjoyed this session and you learned a lot while writing a script with me step by step and looking at tips and tricks here and there along the way. Thank you. Thank you, everyone. That was the end of this scripting session. I hope you were able to follow it up all the way. So a bit shorter this second session just to finish up. And I think it was good to see a few best practices as well along the way. We do have time now for Q&A, so we might jump into that.
Thanks, Jen. Thank you very much for that. Now we've got a couple of questions, but if anyone else has any questions, feel free to push them through. What key did you use to indent the line?
Yes, so in Notepad++, you can see me, that's the things you don't see through the screen like that. You can see me pushing a line. It's literally a tab, that's all it is. So it's one tab further. It helps to organize the script and make it as readable as possible. So whenever I open a loop or if I have a condition like if something, then do something, the line that's the action, I will always indent it one tab to the right so that you can clearly see the loops. And I don't know if you paid attention as well, but in Notepad++, you can also minimize the content of one loop. If you've got a full loop that says, as long as this is happening, please play those actions, then you can minimize all that. And that means that if you have a script that's a little bit longer, you can minimize it and have a bit of a better overall view for it.
That rolls into our second question. Notepad++, how did you get it to do all the color coding? Like when you were selecting a specific variable, it was highlighting all the other variables that you had used. So
yes. Yes, so I see it. So basically, I just need to double click on a word. And by doing that, Notepad++ automatically highlights that same word that it can find through the entire script.
as well as the color coding within Notepad++?
Oh, sorry, I misunderstood your question. I thought about the looking for a script. So the question is probably more about coding the lines as to what they include. And so the idea is that Notepad++ does that automatically once you have saved the file as a JavaScript file. So you might have different color coding depending on what file you are saving. But that only happens once you have saved the file. So when you just first open Notepad++ and you start writing in there, it won't have any colors, like the comments will not be in green. So usually what I do is that I just save it straight away as an empty file. I save it as a JavaScript, so a .js file straight away locally on the machine, and then it will color it automatically.
What scripts have you seen users create? Do you have any favorites?
Ooh, we have got some customers that have invested very heavily into scripting, And there are people out there who have really great ideas. So it would be hard to say a favorite, and I'm not aware of all of them either. Um, huh, what could I think of? There's a few, like there's some that I've seen that I find quite handy to kind of do some easy modeling quickly, like you click a point and it includes a tree where the tree is. So if you wanted to have, instead of having a topo plan in 2D, you kind of want to model a whole street in 3D straight away, you can have someone kind of clicking just the key points, a bit like a virtual surveyor, I would say. And I thought these were good because um, that's something we haven't seen yet in this first script, but within a script, it's actually possible to create your own dialog box. And so it defeats a bit the purpose of full automation, but that way though, you can adapt a bit the script, and that helps you to create really your own algorithms, but have the user have a bit of an input still in what's happening. So I'm just thinking of that one example where, yeah, the client has they're doing extraction, automatic extraction in streets, and so the script first opens a dialog box that asks the user for a few things, and so the user could say, yes, that's for a level of detail that, a certain level of detail, or is it, what's the scale of it, and a few questions like that, and then it runs the script, which means the script adapts to a couple settings and can play different scenarios potentially. So you don't necessarily have to write a separate script for every single extraction that you're doing. You can kind of combine it all in one and then just have a few options at the top. Like exactly this script we have written now, you could have a dialog box at the start that says, which class would you like to extract? So, because we wrote the pipe one straight in the script, but you could ask the user to just enter that or choose in a list potentially. So there's definitely a lot of potential in the script, and I like when people use the full potential of what's available.
Would it be possible to expand this script to model pipes as well?
I believe so, to a certain extent only though, because for those of you who have played with the pipe run and the scan to pipe in 3DR, it is heavily it asks the user to click all those points and to manage the extraction as you go. So this is the limitation about scripting, is that you lose the advantage of it as soon as you need too much user interaction, and so you can't automate things that really need the user to act every single time. So for example, another one that's not really doable that easily in script is cleaning a point cloud manually. You'd have to know the area already in advance and so on. So there are some limitations in what's possible to script. I've got no doubt this will be improved, and new functions will be available to automate that a bit more concerning the pipe modeling itself.
Okay. Do you recommend having smaller scripts or one large script for a set of processes?
That's a very good question. I like writing a whole workflow potentially in several scripts, several smaller scripts. And the idea being that a script can always be cut in different steps that you will be doing. So I like to validate each step on its own and then play it together. And so the idea being that you would write the first step and validate it and keep that on the side, or and then write the second step, so that you really make sure that everything works before you go to the next stage of it. Otherwise, it becomes harder to debug and find where the error potentially comes from. So I think that's a bit more personal preference probably. You can obviously write everything within the same one file, the same one JavaScript file. For maintenance of the script in the future, if it needs to be modified and improved, I think it would be easier to have it in separate scripts. And it is absolutely possible to organize your different steps in the script and have one script that's the main script, and this one calls other JavaScript files. So that's a little bit more advanced now. But if some of you have looked at some of the script on GitHub, the 3DR platform that has those scripts online, you will find a few scripts that are written like that. I'm thinking typically of the rail extraction one. It is written in several scripts, and you've got one main one that will call the others. And the way this one is written is it's got one JavaScript file that actually includes all the settings. And so, for example, in the script we've written today, you could have a separate JavaScript file that has the classification model name and the class name. And that would be useful if you have quite a few settings throughout. Obviously, when you have it just a few things, it's simpler to keep it together. But that would be my recommendation. Let's say, but in several steps to make sure you validate each one.
All right, Jen, we will.
I think we had one more. I see
Oh,
one more question.
I did answer it directly.
Okay, no problem. So we can still answer that one if we want. Well, I guess we still have a minute, right? Yep. So where someone was asking if it was a requirement to have a tab. So that refers to the first question we answered. So a tab at the front of the line when we have a condition happening. I don't think so. I don't think I would say no to that. It's not a requirement. It can do it. It will just read it. It's just for visualization purposes. Hopefully that's what you answered, Joel.
Oh, looks like I passed scripting 101.
Very good.
It's not required, but it's recommended. But you definitely had more detail.
Exactly. That's right.
So that wraps up all of the questions. We've got 2 more webinars to close out the end of the year. Did you just want to give everybody a quick introduction on what we're doing on the 3rd of December?
Yes, thank you for that,
So this
Joel.
is elevation-based mesh coloring.
Indeed. So there's going to be 2 more webinars coming. So one is next week and one a bit further in December. And this time we'll do 2 different scripts. So there'll be 1 different script for each session, and each one on a different theme. So that's why you see that's how you will see different functions being used. So the next script, the main idea is to understand how to color a mesh and what are the functions to call in 3DR to modify that color scale. So what we will see is that we have a simple DTM, a mesh of a terrain, and we will color it per elevation. So that's a simple function in 3DR. So you'll discover how to use that one in script. And then we will see how to display that color scale and a few of the tools on how to modify it as well, as this would be a useful thing to do in script to adapt the color scale. And the next script later, the next session after that, we'll see a little bit of that as well, how to modify a heat map, but in another example where we will go a bit further and actually do a comparison between a mesh and the point cloud, so a little bit further. And what we hope is that you'll all feel, after those sessions, you'll all feel a bit more confident about starting to script yourself and starting to write your own scripts.
Feel a little bit more inspired. All right, we're going to wrap it up there. I think that covers everything for now. I did put the links directly into the Q&A for you to register for the last 2 webinars, and we will see you guys there. Thank you very much for attending. Thank you, Jen, for running this.
Thank you, Joel. Thank you, everyone.